Well, let me start off by thanking you for taking the time to attend today's presentation. My name is Lance Zurich, and today we're going to take a brief look at the two special curriculum-based sets that are available from Studica that are designed specifically for introducing middle schools, high schools, and homeschool environments to the fundamental principles behind mechatronics. Now, each of these sets were designed for conducting a project-based class, and that's essentially where students are required to work together and design and build a series of original prototypes based upon their research and activities. And each of these sets includes standards-focused curriculum, which was created especially for Studica by noted educator and STEM expert Tom White. So today we're going to start off where so many of these technology-focused presentations for education will start, and that will be with discussing the skills gap that exists. Now, when you hear someone talk about the skills gap or the need for more STEM education in the schools, STEM, of course, being an acronym which stands for science, technology, engineering, and mathematics. Well, when you hear someone saying this, what they're really talking about is the urgent need to prepare our students with the background they're going to need to require them or to allow them to successfully compete in the job market that they're going to be graduating into. In the employment market that once greeted our parents and grandparents and then those before us, a good work ethic and a strong back and being able to take direction along the way might have been enough to land a good paying job where many of the technical aspects could be learned on the fly. But now students must be prepared to enter a world that is increasingly focused on programming and automation and IoT and all sorts of rapid advances in technology. And because of this, students must be able to demonstrate technical literacy and aptitude if they hope to compete and, of course, if they hope to succeed. And this is why so much of the emphasis in education over the last decade has been on developing STEM skills. Obviously, every new advantage that we enjoy, everything from the smartphones and tablets that we all use, were created because of individuals who helped to make those types of advances. Now, when you look around the world, there are countries all over, countries like China and India and many others that are making major strides in developing new technological advances and preparing their own students to take their place in the future workforce. Now, here in the United States, we also need to prepare the next generation of graduates with the skills, the mindset, and the habits that are going to enable them not only to secure jobs, but also, again, to be part of that next wave of advancements that we're going to rely on to stay competitive on the world stage and to maintain our stature as a world power. Now, as I have no doubt that anyone who's attending a webinar like this is in agreement about the importance of STEM education and technology programs, we're going to instead move right along to the main topic, which is, of course, mechatronics. Mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science, all extremely important subject areas for students to be exposed to, and all skill sets that are highly prized in today's technology-focused job market. But, well, just how highly prized am I talking about? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, of course, they need to start developing these habits and the career focus as early on as possible in high school, if not even in middle school. Now, the dilemma for educators, whether you're in the classroom or even in the homeschool environment, is finding ways of introducing this type of subject matter to students in a way that gets them interested and involved in the learning process, and not just focusing on memorizing obscure facts in a way that, just to take a few tests and promptly forget about them. To really help students to be successful and to encourage them to consider pursuing further education in subject areas like this, educators need to be able to present the material in a way that makes it relevant, which of course means answering that eternal student question, which is, why do we need to know this? And it also needs to be engaging in a way that holds students' attention better than textbooks and lecture presentations and things of that nature. And it has to be something that has visible real world applications and where the students can get involved in doing things hands-on. Now, it's with this in mind that we created the Studica Mechatronics programs. These are two special sets, one of which is designed as an introduction to the world of mechatronics, and the other which is intended to be essentially a standalone class dedicated to this subject. These were created to provide all of the materials in one place that educators would need to enable them to offer a project-based class that's relevant, engaging, realistic, hands-on, and of course, which is crafted to meet the most current academic standards. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document, which again was created especially for Studica by noted educator and STEM expert Tom White. The curriculum itself comes as a downloadable PDF, which is available for free with the purchase of each set. So whether you buy one set, whether you buy 20, you automatically get that curriculum. Now, this curriculum is designed to align to the most widely accepted academic standards currently in place in the United States. And the curriculum was also designed for offering a project-based learning program, as I touched upon before. And again, this means that solving the problems that are going to arise in each unit will require the students to be actively involved in the research, the design, the trial and error and experimentation, and all activities, and in the building of actual working prototypes that are going to help to provide the answers that they require. And again, students aren't going to be asked to do this alone. They're going to be asked to work in small groups or teams of 4 students per group. And this is going to help to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And when I'm talking about things like soft skills, I mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And finally, with the exception of some very affordable software, actually, it's not even affordable anymore. We give it to you for free. With the everything is basically included in the physical set. We will give you a download of the software, but all of the materials you need now to enable you to address all of the design projects presented through the course of the curriculum are presented right inside the box. Now, the curriculum is designed to enable teachers of all backgrounds, even teachers from non-science or technology-focused disciplines, to have the information they're going to need at hand to properly prepare them for conducting the activities, and also to help increase their own comfort in presenting this material to their students. The curriculum is designed to be clear and easy to follow, providing a clear roadmap for student learning. Now, there are various supplemental materials that are included along the way, both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorials on familiarizing students with the building system they're going to use to address the various projects that are presented to them in each unit. The units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging real-world style scenario where students again have to work together in small teams of 4 students per group to find a solution to the problem. The project units each contain embedded academics, and at the end of each of these units, students will be required to make a formal presentation of their prototype that they've created to address that particular unit's real-world scenario, the problem that we were talking about, and they have to explain their reasoning behind the way they constructed their prototype and why they made the choices they did. There's a technical literacy task that's driven by each of these projects. As students work to address each of these projects, they're going to acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are all acquired through the carefully designed enabling activities. And again, as required by each of these projects, students are going to be asked to create original prototypes, and of course, any required programming-based solutions, they're also going to be responsible for creating that as well as maintaining detailed documentation of the entire process. Now, as I've name-dropped them a couple times already, again, the curriculum that accompanies each of the Mechatronics program sets was created especially for Studica by a man named Tom White, who you see on your screen now. Now, Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s. He's well known for designing programs used for both educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom has been pivotal in introducing subject areas like CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, the standards addressed in the Studica Mechatronics programs are the most widely accepted standards that are currently in place in the United States. This includes the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K to 12 and the standards for technological literacy. Now, as I mentioned earlier, the programs are designed to be project-based. Now, when students ask, why do we need to know this? What this really means is that the subject matter that they're being presented with might come across as too abstract to ever be useful in their lives. But with this project-based approach, students get to see firsthand why these things are necessary to know and why they're useful to know. The concept, again, of working in the small groups to solve these projects and problems also helps students, again, to develop those high demand soft skills that employers look for. Again, things like communication, analytical skills, quantitative skills, flexibility, adaptability, and problem solving. Now, in this project-based format, all of the subject matter is integrated. And what I mean by that are things like the math being integrated with the reading and the writing and so on, which this kind of format is really ideal for STEM education. Also, because of the manner in which students must approach each of the projects being put forth in the curriculum, and by this I mean with the research and the testing and the group give and take to just provide a couple of examples, this allows for a much deeper exploration of problems than traditional teaching methods might allow. The projects presented in each unit are also designed so that if you have several groups working on the same project, you should see variations in the types of prototypes and solutions being offered by the students. Now, this, of course, could be because of differences in creativity, differences in research, and different approaches taken by each group. But in any case, students get to see firsthand that problems can have many different answers, many different solutions, and that there's not often only one right answer, but there can be several. Each project in the curriculum presents students with the opportunity to plan, to organize, and also to conduct research. The enabling activities that students are asked to engage in will provide them with the skills and knowledge they need to draw on to complete each project just in time. And students will be required again to do extensive research as they complete these projects. Research that is utilized in the design, the prototyping, the testing, evaluation, and redesign phases of each of these solutions. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. Now, this team approach, again, as stated before, helps to promote the soft skills, things like communication, ability to work well with others, and leadership. And the sets offer an easily scalable approach. You can just divide the number of students in your classroom by 4 to determine the number of sets that you'll need for each class. And once again, everything you need to conduct the program, aside from the software, which, like I said, is a download, which we will provide you with, everything else is physically included inside of the box. Access to the free curriculum download, again, is included with the purchase of each set, and also included are all of the building materials which the students are going to use in the creation of each of their prototypes. These materials are taken from the unique Fisher-Technic building system, and among the components included in each set are 2 robotic controllers and 2 power supplies. Of course, many of you may not be familiar with Fisher-Technic, so just allow me a minute or two to give you a little bit of background here. Fisher-Technic is a flexible and innovative construction system. Now, unlike a lot of other popular construction sets that are designed mostly to stack, Fisher-Technic was created with more of an engineering mindset. Now, if you see the example that's shown on the screen, you see the core building block in the system, and the core building block in the Fisher-Technic system is unique in that it allows attachment from all six sides. And because of this, it allows for almost limitless design possibilities. Many of the parts used in the system are designed to slide together and lock in place using a tongue and groove assembly method. And the system itself includes a wide selection of very specific parts. And by that, I mean different variations on gears, girders, sensors, axles, and much more. And this will allow technical builders to address equally specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both the construction and the automotive industries. Now, Mr. Fisher, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime, which is pretty impressive. Now, besides Fisher Technic, Mr. Fisher is known as the inventor of synchronized flash photography, and that was back in 1949. And he is also credited as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, still employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as many components used in automobile manufacturing. And they also provide high-end consulting services related to automated processes. Now, with all that being said, let's begin by looking at each of the two individual sets. And we're going to start off with the Studica Introduction to Mechatronics Program set, or for those of you who like acronyms, you could refer to it as SIMP. The set is designed to help provide a well-rounded introduction to the core concepts of mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, again written by Tom White. The curriculum contains enough activity material to fill approximately 45 academic hours. As such, with this set, we recommend it for insertion either into regular related class activities, for use as a short class unto itself, for after-school use, or of course, for homeschool use. The curriculum, again, is created to be standards focused, again, using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based program. The set is designed for use in middle school or high school classes, or again, for addressing these same grade levels in a homeschool environment if you prefer. The set itself contains a collection of over 700 Fisher Technic building components. And again, this is going to be everything from gears and wheels and axles and blocks and sensors and much, much more, as well as the two robotic controllers and power supplies, which I mentioned. And only, again, the software itself, which we will provide a link to download. So everything else is basically right inside the box. Now, the curriculum for the Studica Introduction to Mechatronics program set consists of 6 project units, and they are as follows. There's one on sketching and documentation, one on simple machines, mechanical systems, basic electricity, the conversion and storage of energy, and an introduction to control systems. And there are also activities included to address the following topic areas as they come up during the course of the curriculum. And this includes things like sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using software and robotic controllers, working with sensors like the digital switch and the digital photo transistor, working with open loop and closed loop programming, as well as digital branching, working with analog sensors such as the photocell LDR, working with analog branching, and additional analog sensors such as the NTC resistor and the potentiometer. Now, before we go further into the structure of the curriculum itself, let's first look at what's covered by the second set. Now, the second set is called the Studica Teaching Application of Mechatronics Program. And in this case, if you want to use an acronym, you could call it STAMP. The set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. Now, this set will come with access to a free downloadable 400-page curriculum document entitled Mechatronic Applications, again by Tom White. And the activity materials in this particular document, when used in conjunction with the components of this set, are designed to fill approximately 180 academic hours. So essentially, we're talking about 4 times the amount of academic hours being covered as were covered by the previously discussed set. And because of this, you can think of this as a more expansive version of the material being touched upon in the previous set. And it's really designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day, 5 days a week, or the equivalent for a full academic year. Again, the set is designed for offering students a standards-focused, project-based learning experience, and it's designed again for use in middle school, high school, or of course for addressing those same grade levels in a homeschool setting. The materials in this case will consist of a selection of over 1,200 Fisher Technic building components, again, a wide range of blocks and gears and sensors and so much more, your 2 robotic controllers and your 2 power supplies, and your downloadable software. Now, there are twice as many project units included in the Studica teaching application of Mechatronics program set as with the previously discussed unit, and this will include units on sketching and documentation, simple machines, mechanical systems, basic electricity, and that's followed by project-specific units on things like the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, there are links that are provided to tutorial sections and activity materials for students to utilize to help to bring them up to speed with different concepts as they're addressed. And again, this will include things like sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, using the programming software and the robotic controllers, working with open loop programming, working with sensors such as the digital switch and the digital photo transistor, working with closed loop programming or digital branching, learning about logic gates and combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, learning how to record positions, creating a graphical user interface, working with analog sensors such as the photocell LDR and the NTC resistor, and working with analog sensors like the potentiometer, and also working with data. Now that we've had a look at how each of these sets differs, and we've had a look at the specific subject matter that are being covered by each, we're now going to focus on the curriculum itself and how it's structured. Now, both versions of the curriculum will share the same essential format that we're going to see. So, and as already discussed, each unit is going to include tutorial materials, activity materials, standards, and supplementary materials. Now, in each case, this curriculum is designed to be turnkey. And what I mean by that is that each unit is designed to clearly spell out everything that's going to be addressed and to provide access to tutorials and other information as these topics arise. And this was done specifically to enable students to get very comfortable with the concepts, but also the teachers who are teaching this, and especially because the teachers come from all sorts of different backgrounds, including very often non-technical backgrounds who end up teaching STEM or robotics classes. So this is done so that basically by reviewing the material, a teacher should be able to quickly become comfortable with delivering it in the classroom setting. Each unit presented in the curriculum for these sets includes the following sections: an introduction, a discussion of the purpose of the project and the concepts, an outline, the standards that are addressed, assessment rubrics, the essential question and student scenario, a daily plan, vocabulary words and terms, and resources. Now we'll take a look at each of these areas a little closer. Now, the introduction and purpose of the project is, of course, just as you would gather, this is the section that provides a brief description right at the top of what's going to be explored in the coming days and activities. And it also seeks to clearly spell out to the students why they're learning this material and why it's important for them to know. The next section focuses on the main concepts to be addressed in this particular unit. And this can be thought of as the broad ideas that are going to be explored in the unit and the core information that students should take from this project that's going to be essential for them to understand and utilize, not only today, but also the types of things that they're going to draw upon as they move forward in STEM-related fields of study, and of course, if they choose to pursue it further in STEM-related careers. Now, following this, we encounter the outline. And in the outline section, we'll drill down more specifically to what's going to be addressed in the unit. Now, as the example that I'm sharing on the screen right now is taken from the unit that addresses aspects of programming, you'll see again that we touch upon areas such as the methods for writing programs, whether it be flowcharts, word problems, etc. Program characteristics, for example, open or closed loop. Branching, whether it be digital, analog, subprograms, and so on. The next section of each unit focuses on the specific academic standards that are going to be addressed in the unit. As you will see, this includes the college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and this is going to include rubrics both on the specific project being covered, as well as general rubrics for literary tasks. Next, we encounter the essential question. This can be thought of as the big picture question that is going to be focused on each of the smaller individual activities that are going to be encountered in the unit. And of course, all of the aspects of the larger project with students are going to be asked to complete in this section. Now, when we are presented with the student scenario, this is where the specifics of the project to be addressed are finally spelled out. And the student scenario is presented in the context of a real world style scenario where students are going to be asked or presented with a problem that needs to be solved by the creation of some sort of a device, a machine, a mechanism, what have you. Now, as I mentioned before, students aren't asked to do this alone. They again have to work in teams of 4 students each to craft their answers to this particular challenge. Solving this problem is going to require each team of students to design a unique and original answer, which once again is usually in the form of a working prototype, along with whatever programming might be required to control it. So just to provide an example, if you look at the student scenario that I have on the screen right now, you'll see that this is a project in this unit where each of the students takes on the role of a member of a design team where they've been employed by a firm that manufactures garage door openers. Now, in this particular case, students are being required to design a specific type of control system for a new line of garage doors. And the manufacturer's requirements are all spelled out here, and it includes things like the use of limit switches and meeting certain safety codes that require a method for sensing, for example, if anything is the way of a closing door, and also the incorporation of an automatic light. So again, each team of students is going to be tasked with creating both a unique and original prototype, and in this case, of course, that's a garage door opening system. And they also have to, in this case, create the programming needed to control the prototype. Now, as they move through the challenge being put forth in the scenario, each student team is going to be required to document the entire process in both a design notebook and also in a digital engineering journal. And they have to notate all of the research, all of the trial and error experiments. They have to keep copies of all designs, sketches, and revisions, and so on. And at the very end of each project unit, as I've mentioned before, each team of students is going to be required to make a formal presentation in front of the class, during which they will be asked to demonstrate their prototypes and the programming in action, much as they would be required to do for an actual employer or client in the real world. Now, the next section that we encounter is the daily plan. And this is the section that spells out clearly, both for students and teachers, what's going to be expected of students, how the teacher is going to conduct that day's classroom activities, on what specific subject matter is going to be covered. Now, some days may involve, for example, discussions. Other days may be more focused on research or in building small projects that help provide the building blocks, so to speak, that students are going to draw on to complete the larger projects as described in the student scenario. But in any case, you can really think of the daily plan as a roadmap designed to keep everyone, students and teachers, on the same pathway. Now, you'll see too that along the way, as different aspects are addressed in each day's activities, such as, for example, what's required in the design notebook, or how do you use the control software, or work with the controller, or with flow charts, or what have you. As I mentioned before, there are links to sections to provide further instructions and information on each of these areas. Now, again, at the completion of each unit, after the last day of the daily plan, there's a section containing the vocabulary. And this is important words and terminology that are introduced during the project unit, as well as a selection of useful resource materials. Now, the resource materials could be a mix of different types of things. You might find carefully vetted websites and video links. You can have PDF documents, PowerPoints, much more. It's going to depend on the unit at hand. Now, besides these project units, each of the curriculum documents also includes a special tutorial section designed to educate both students and teachers on how to use the Fisher Technic building system. And this will include information on how the various parts fit together using, again, that tongue and groove assembly method I touched upon, how to identify the different types of parts from the various types of girders and blocks, the different types of axles, gears, rivets, and so on. And students are also going to be asked to build a very basic sample model just to help familiarize them with the system before they move on to the larger projects that they're going to have to create in each of these units. And again, is learning about and maintaining proper documentation is one of the areas that is stressed in the course of the curriculum. There's also a section which details just what defines each type of documentation listed on the screen now and what is going to be required for each. And as the process of conducting these types of more open project-based class activities may also be new to teachers, there's also a section that discusses specifically project-based STEM education and its benefits, which will hopefully answer some questions you may have about it. Now, that completes our overview of the two sets. And with that all in mind, let's quickly review the contents and purpose of each set, but this time we'll provide the pricing. Again, we started off with the Studica Introduction to Mechatronics Program set, which is designed as a standards-focused, project-based introduction to the core concepts behind mechatronics. Again, this set includes a highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted educator and STEM expert Tom White. The curriculum, when used in conjunction with the building materials in this set, will provide teachers with enough activity materials to fill approximately 45 academic hours. And again, because of this, it's designed for those educators who wish to offer a shorter form class on this material, who wish to incorporate it for after-school activities, or of course, for those who want to use it for homeschool use. The teaching material is designed for use again in middle school and high school level classes, as well as by homeschooling parents seeking to address the same grade levels for STEM and mechatronics. The physical materials in the set will include a selection of over 700 components from the Fisher Technic system, along with the two robotic controllers and the power supplies. And again, these materials will be used to construct the mechanical prototypes addressed in each project unit put forth here, and the software download is provided. Again, each set is designed for use by teams of 4 students at a time, and the pricing starts at just $699 per set. And there is also discount classroom pricing available for groups of 20 students and up, and that's available upon request. We're happy to provide that for you. Next, to continue our review, is the Studica Teaching Applications of Mechatronics Program set. And again, this is designed as a more in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, and it's all built around a 400-plus page curriculum document entitled Mechatronics Fundamentals, again, written by Tom White. Now, when using in conjunction with the building materials included in this set, the curriculum is designed to provide enough activity material to fill approximately 180 academic hours. So again, this is 4 times the amount of material, and because of this, it's really designed for those who are able to dedicate a daily class period of 50 minutes a day, 5 days a week, or the equivalent. If you did one large class on one day a week, you could do that, or however, but that you're going to have to set aside that much time for this, essentially 50 minutes a day, 5 days a week for a full academic year. Again, it's designed for use in middle schools and high schools, or for addressing those same grade levels in a homeschool environment. Each box is going to contain 1,200 components from the Fisher Technic system, including the robotic controllers and the power supplies. The software is provided. We provided access to a free download of that. Again, each set is designed for teams of 4 students, with pricing for a single set starting at just $799 each. And again, discount classroom pricing for 20 students or more is available by quote upon request. The software, just to briefly mention here, it is Fisher Technic RoboPro that is used with these programs. It's graphic programming software, uses the flowchart style design where students can create their programs basically by linking them up in, a flowchart style design. As I mentioned, it's for use specifically with Windows 7, 8, or 10. It does not work with Chromebooks. It's not designed for Mac computers, unfortunately. Again, this is absolutely free. We provide a download link for this, so you get this along with your set. So on that note, if there are any questions, I will leave this up for a second. You can type in any questions you might have in either the webinar chat window or the question and answer window. If I don't see anything come up, I will move right along. So if you would like to take a next step, if you'd like to request a quote, if you would like to speak with your dedicated educational representative, you can call us right here. Our number toll free is 888-561-7521. General quote requests and inquiries, you can email us at info@studica.com. But if you have any specific questions about anything I discussed or anything I didn't mention, or any aspect of not only this program, but also of any of the Fisher Technic products we offer. We are the U.S. distributor for Fisher Technic education and simulation products within the United States. So if you have any questions about any of those products, you can email me directly. And as you see, my email is lance.zurek, that's lance.zurek @studica.com. So on that note, we thank you very much for taking the time to attend today's presentation. We hope you have a great afternoon, and we look forward to hearing from you soon. And have a happy and safe holiday as well. Take care.